objects. Okay. Now, so what we are going to do is we try to use our knowledge for elastic collision to calculate the coefficient of the restitution for the elastic collision. Okay, so we're going to see it exactly equals to 1. Okay, we're going to do this calculation. Before that, let's first look at this completely inelastic collision. Can you see immediately that by definition it has to be 0 because C equals to U2 minus U1 divided by V1 minus V2. For completely inelastic collision, they stick together, right? They have the same velocity after collision. So U2 equals to U1. If U2 equals to U1, of course, this is 0 divided by V1 minus V2 is always 0. Okay, that's straightforward from the definition. You can see the C equals to 0 always for the completely inelastic collision. Now, for elastic collision, let's do the calculation. For elastic collision, we have two equations, right? Momentum conservation kinetic energy conservation. This is M2. Okay. Now we try to use the two equations, solve the two equations to calculate the coefficient of the restitution, C. Okay, so we want to calculate C equals to U2 minus U1 divided by V1 minus V2. Okay. So basically, this is just a standard algebraic equation. You have two equations. You want to solve the two equations to get some expression for U2 and U1. The basic idea is that here, again, you don't have any number. But you can think about all other unknown quantities. The only unknown quantity, suppose, is U1 and U2, and U1 and U2. Okay. So, many of the students may have trouble to solve this if you don't have a number. But you can imagine if you put a number for all other quantities. So you only keep U1, U2 as your unknown quantity, right? Okay. You can just make some number for them and to see what's going on. Now, our unknown quantities U1, U2, and all other unknown quantities. We try to solve this equation. There are some trick here, so I would like to solve it. It's a purely mathematical problem, but there is some trick. Okay. So, of course, the first thing you want to do is to simplify the second equation. Every term contains a 1/2, so you can actually cancel the 1/2, right? So the second equation actually becomes to this is equation 1, this is equation 2. So equation 2 will become m1 v1 squared plus m2 v2 squared plus equals to m1 u1 squared plus m2 u2 squared. Okay. So this is equation 3. And now I'm going to do some rearrangement for equation 1 and this equation 3. Okay, the modified second equation. The key point here is I'm going to move, okay, this equation you can look at how we put the numbers. And left hand side, they correspond to the initial state, right? Initial velocity. And the right hand side, it corresponds to the final state. Now I'm going to rearrange it in like this. I'm going to put m1 v1 here and move m1 u1 here, so it's become negative m1 u1. And then we have m2 u2 here, and I'm going to move this term to the right hand side. It becomes m2 v2. So all the term related to mass 1, I put it on the left hand side. All the term related to the second object, I put it to the right hand side. Okay. So here you write the equation in terms of initial state and final state. And here I rearrange the equation in terms of object 1 and object 2. Okay. I'm going to do the same thing for this equation. So you get m1 v1 squared minus m1 u1 squared equals to m2 u2 squared, minus m2 v2 squared. Okay? Any question here?
Did you multiply equation 2 by equation 2?
Yes. I multiply every term by 2, so I get this. Okay? You don't need that 1/2. It cancels. Every term becomes just 1/2. Okay, now the next step will show why I want to rearrange to that. You probably can see. Because after we do that, on this side, I can factor out m1, right? So it becomes m1 v1 minus u1. Right hand side becomes m2 u2 minus v2. This equation, you can do the same thing. You can factor out m1. So you get v1 squared minus u1 squared equals to m2 u2 squared minus v2 squared. Okay. I'm going to put this is equation 4, this is equation 5. Okay? And then I'm going to use equation 5 and divide it by the equation 4. So that means left hand side divided by left hand side, right hand side divided by right hand side. So I get m1 v1 squared minus u1 squared divided by m1 v1 minus u1 equals to m2 u2 squared minus v2 squared divided by m2 u2 minus v2. Okay. And if I do so, this m1 cancels this m1, this m2 cancels m2. Okay. So we don't even have mass here in this equation. So I can do some further simplification. Do you remember that if you have a squared minus b squared, so this actually equals to a plus b multiplied by a minus b, right? Okay? And so you can expand this. It becomes v1 plus u1 multiplied by v1 minus u1 and divided by v1 minus u1. This side you get u2 plus v2 and u2 minus v2 divided by u2 minus v2. And after that, you can see I get a big cancelling, right? This v1 minus u1 cancels this v1 minus u1. This u2 minus v2 cancels u2 minus v2. So actually I get v1 plus u1 equals to u2 plus v. Okay, first let's pause here a little bit. Okay, when we solve the mathematical equation for the physics problems, it's always good. Let's think about the meaning of each equation. Okay, because the most important thing for us is to think about the meaning of the equation. Mathematics is our language, it's not our purpose. Can you see there are some physical significance of this equation? This is the initial velocity of the object 1, final velocity of object 1. This is the initial velocity of the object 2. This is the final velocity of the object 2. So it actually says that if you add the initial velocity and the final velocity for one object, it should equal to the initial velocity plus final velocity for another object. Okay, so it's kind of conservation law. Okay, for elastic lesion. Okay, and then from that, let's rewrite it. So this one you can write it as on right hand side. That's for u2 minus u1. Left hand side is v1 minus v2 if I switch the things, right? And from this, you can see that u2 minus u1, this u2 minus u1 equals to v1 minus v2. So u2 minus u1 divided by v1 minus v2 equals to 1, right? Any question here? And of course, this is the definition of the coefficient of the restitution, right? Okay. So we proved that C equals to 1 for elastic lesion. Okay, any question here? So here you can see here we use some trick I hope you can think about. We rearrange to put one object on the left hand side, one object to the another object on the right hand side. The reason is that then we can cancel mass if we divide the energy equation by the momentum equation. Okay, and then we can further apply this trick to get more cancelling, so we get some simple equation, simple relationship between the velocity that will give us this, okay, the coefficient of the restitution. Any question here?